In the stillness of the tropical forest, dawn breaks slowly. Mist clings to the canopy above, and the jungle floor appears peaceful, almost serene. But beneath this calm exterior, something ancient stirs. Then, in an instant, the forest floor erupts into motion. A living river of Bodhis emerges from the undergrowth. Millions upon millions of tiny warriors march forward with a single, unified purpose. They are the army ants, and when they move, everything in their path faces a simple choice: flee or be consumed. This is not merely an insect. This is a superorganism, a collective intelligence composed of hundreds of thousands of individuals, each playing its role in one of nature's most formidable hunting machines. Together, they form what scientists consider one of the most successful predatory forces on Earth, a phenomenon that has existed for over 100 million years. Welcome to Wildlife Phase. Today, we journey into the microscopic world of these tiny terrors, where survival depends on numbers, coordination, and an unstoppable drive to consume. This is the story of the ant army that eats everything in its path. Spanning across the tropical belt of our planet, from the dense rainforests of Central and South America to the humid jungles of Africa and Southeast Asia, army ants have established their dominance across 3 continents. In the Americas, the legendary Citon roams the forest floors of countries stretching from southern Mexico to northern Argentina. These rainforests, receiving between 80 and 400 inches of rainfall annually, create the perfect hunting grounds for these voracious predators. The warm, humid conditions maintain temperatures between 70 and 85 degrees Fahrenheit, ideal for ant colonies that cannot regulate their own body temperature. Across the Atlantic, the African continent hosts its own formidable army ant species. The Doralus genus, commonly known as driver ants or safari ants, patrols the forests and savannas of sub-Saharan Africa. Here, colonies reach staggering sizes of up to 20 million individuals, making them the largest ant colonies on Earth. In the forests of Southeast Asia, yet another lineage of army ants has evolved independently. These Asian species, though less studied than their American and African counterparts, demonstrate the remarkable success of the army ant lifestyle across diverse environments. What unites these distant relatives is not just their predatory behavior, but their nomadic existence. Unlike most ant species that build permanent nests, army ants are perpetual ones. They carry their entire colony, including their queen and developing young, as they march through the forest in search of prey. This mobile lifestyle has made them masters of their domain, capable of exploiting resources across vast territories. Among the army ants, Citon burchelli stands as perhaps the most studied and certainly one of the most impressive. Found throughout Central and South American rainforests, this species has captivated scientists for over a century. A typical colony contains between 300,000 and 700,000 workers, though some colonies have been documented with over 1 million individuals. The queen, the colony's reproductive center, measures approximately 2 inches in length and can produce between 100,000 and 300,000 eggs during each reproductive cycle. She is the largest army ant queen in the Americas and one of the longest, surviving up to 15 years in some documented cases. Unlike many ant species with just 2 or 3 worker types, this species has evolved a remarkable diversity of body forms, each specialized for different tasks. The smallest workers, measuring just 3 millimeters in length, serve as nurses and tend to the developing brood. Medium-sized workers form the bulk of the foraging force, capturing and processing prey. Their enormous jaws, while formidable weapons, are useless for handling food. The colony operates on a strict 35-day cycle. During the statory phase, lasting approximately 20 days, the colony remains relatively stationary while the queen produces her eggs and the larvae develop. Then comes the nomadic phase. For 15 days, the colony marches daily, sometimes covering distances of 300 meters or more in a single day, hunting constantly to feed the ravenous larvae that travel with them. When army ants hunt, they do so with overwhelming force. The swarm raid, as scientists call it, is one of the most spectacular hunting strategies in the animal kingdom. As dawn breaks, scout ants emerge from the temporary bivouac, the living nest formed by the ants' own body. They fan out across the forest floor, laying chemical trails that will guide the main hunting party. Wheatenors, a massive column of ants, begins to flow outward, sometimes stretching over 100 meters in length and 20 meters in width. At the raid front, chaos reigns. Ants pour over every surface, investigating every crack, every crevice, every hiding spot. Insects that have remained motionless are discovered. Spiders are overwhelmed. Scorpions, despite their venomous stingers, fall to the sheer numbers of attackers. Even small vertebrates, if they fail to flee in time, can become victims of the swarm. The ants employ a remarkably efficient processing system. Small prey items are carried whole back to the colony. Larger prey is dismembered at the capture site, with different workers carrying different body parts. Scientists have documented the ants capturing and processing over 30,000 prey items. In a single day of raiding, the diversity of prey is staggering. Studies have identified over 500 species of arthropods taken by a single army ant colony over the course of a year. This includes insects from dozens of different orders: spiders, scorpions, centipedes, and even the occasional small frog or lizard that could not escape in time. Yet despite this apparent destruction, the ants are remarkably sustainable hunters. Because they are nomadic, they never exhaust the prey in any single area. By the time the colony returns to a previously raided territory, sometimes months later, prey populations have fully recovered. This nomadic lifestyle, far from being primitive, represents an elegant solution to the challenge of sustainable predation. Crossing to the African continent, we encounter the true giants of the army ant world. The Doralist driver ants of Africa form the largest colonies of any ant species on Earth, with populations reaching an almost incomprehensible 20 million individuals. These formidable hunters have earned their fearsome reputation. Unlike their American relatives who primarily hunt other driver ants are known to attack and kill much larger prey. Small mammals, birds caught on nests, and even animals as large as injured antelope have reportedly fallen victim to driver ant swarms. Though such events are rare and typically involve animals that were already incapacitated, the soldiers of Doralist are equipped with powerful mandibles that can remain locked in a biting position even after the ante's death. In some African communities, these ants have historically been used as natural sutures, their jaws clamped onto wound edges to hold flesh together while healing occurs. They emerge to raid in massive columns, primarily during the night or on overcast days, avoiding the desiccating effects of direct sunlight. Their impact on local ecosystems is profound. When a driver ant column passes through an area, virtually every small creature that cannot escape is consumed. Yet this creates opportunities for other species. Numerous bird species have evolved to follow driver ant raids, not to eat the ants themselves, but to capture the insects and other small animals flushed from hiding by the advancing swarm. These unfollowing birds represent one of the most specialized feeding guilds in tropical ecosystems. Some species depend so heavily on army ant swarms that they rarely forage independently. When ant colonies are absent, these bird populations decline, demonstrating the far-reaching ecological connections centered on these tiny predators. Perhaps no aspect of army ant biology is more remarkable than their architecture. Structures built entirely from their own living bodies. Hundreds of thousands of ants create a living structure that can reach the size of a basketball, providing protection for the queen and developing brood at its center. When external temperatures drop, workers on the bivouac's exterior vibrate their muscles to generate heat. When conditions warm, they spread apart, allowing air circulation to cool the interior. Even more impressive are the bridges and living highways that army ants construct during their raids. When the colony encounters a gap in the terrain, workers will form living bridges, their bodies creating a continuous surface over which their sisters can cross. Studies have shown that these bridges are dynamically optimized. As traffic patterns change, workers will join or leave the bridge structure, maintaining the most efficient possible configuration. They choose efficient foraging routes, avoid areas recently depleted of prey, and coordinate the movements of hundreds of thousands of individuals without any central control. Scientists studying these phenomena have found insights applicable to human engineering, from traffic management to robotics. The army ant colony represents one of nature's most sophisticated examples of emergent intelligence, complex behavior arising from simple rules, followed by many individuals. Far from being mere destroyers, army ants serve essential functions in tropical ecosystems. Their predatory activities help regulate populations of countless invertebrate species, preventing any single prey type from becoming overabundant. The nutrients they cycle through the ecosystem are substantial. A single large colony of doorless driver ants can consume over 500 kilograms of prey annually. These nutrients, originally dispersed across the forest floor in countless small organisms, are concentrated and redistributed through ant waste products and the bodies of dead workers. The relationship between army ants and ant-following birds represents one of the most important ecological interactions in tropical forests. In neotropical rainforests, over 50 bird species have been documented attending army ant swarms. Some, like the ocellated antbird, have become so specialized that they rarely forage independently of ant swarms. When army ant populations decline, these dependent species suffer. Research has shown that forest fragments too small to support army ant colonies also lose their populations of obligate ant-following birds, even when the habitat otherwise appears suitable. The army ants, it turns out, are keystone species, their presence or absence determining the survival of many other organisms. Today, army ants face unprecedented challenges. Deforestation across the tropics destroys the continuous forest habitat these species require. Because army ant colonies need large areas to sustain their nomadic lifestyle, they are among the first species to disappear when forests become fragmented. Climate change poses additional threats. Army ants are highly sensitive to temperature and humidity. Even small shifts in climate can alter their behavior patterns, reduce their hunting efficiency, and decrease colony survival rates. Scientists monitoring army ant populations in Central America have documented concerning declines in some regions, though comprehensive data remains limited. The loss of army ants triggers cascading effects throughout the ecosystem. Without their predatory pressure, some invertebrate populations may increase to damaging levels. Without their swarms, ant-following birds lose their primary food source. Without the nutrient cycling they provide, forest floor processes are altered in ways scientists are still working to understand. Conservation efforts focused on maintaining large, connected forest reserves offer the best hope for army ant survival. These species cannot persist in small habitat fragments. They require the vast territories that only intact tropical forests can provide. The army ants remind us that power in nature does not always come in large packages. These tiny creatures, each one insignificant alone, together form one of the most formidable forces in the natural world. For over 100 million years, they have shaped tropical ecosystems, driving the evolution of countless species and maintaining the balance of forest food webs. Their story is one of cooperation, specialization, and collective intelligence. It demonstrates that complex, sophisticated behaviors can emerge from simple components working together. As tropical forests fall and climates shift, these ancient lineages face challenges unlike any in their long evolutionary history. Their survival depends on our willingness to protect the wild places they call home. Thank you for joining us on this journey into the microscopic world of the ant armies. If this documentary has opened your eyes to the wonders of these tiny terrors, we invite you to share your thoughts in the comments below. Have you ever encountered army ants in the wild? What aspect of their behavior amazed you most? Until next time, remember that even the tiniest creatures can teach us the greatest lessons about survival, cooperation, and the intricate beauty of our living planet.